However, we do need to know a few things about naming. For example, we need to know all these prefixes that tell us how many carbons in the main chain. And in level 2, we do need to know these functional groups. There are 7 of them: alkanes, alkenes, alkynes, haloalkanes, amines, alcohols, and carboxylic acids. At level 3, we also need to know the following functional groups: esters, amides, acyl halides, aldehydes, and ketones. Let's go through naming. The first thing you have to do when you name is to identify the longest unbroken carbon chain. We call this the parent chain. In this example, there are 6 carbons in the longest chain, so this is a hex. We then need to find any functional group so that we know the word ending. For example, in this molecule here, we have a COOH. This would give the word an oic acid ending, as it's a carboxylic acid. In this molecule here, we have an amine, an NH2 group. This would give the word an amine ending or an amino beginning. And our final example, this one here, is an alcohol with an OH group. This would give this molecule an ol ending. The next step in naming is that we have to find any side chains. These will commonly be the halogens, fluorine, chlorine, bromine, and iodine, methyl and ethyl branches, and OHs can be side chains too. Note in this example there are 2 methyl groups. We've chosen the main chain that includes the OH for our main chain. Then we have to make sure that all of these branches or side chains are numbered from the same end. In this example here, we have a methyl, a bromo, and a chloro. We can either number it 334 or 233. So we choose 233, giving us the lowest number. Other points. Carboxylic acids, the COOH, this carbon atom must be numbered as number 1, but we never write the number 1. If we have 2, 3, or 4 of the same thing, we need to use the prefix di, tri, and tetra. If we do use di, tri, or tetra, we must also put in that amount of numbers. i.e., if you say tri, you must use 3 numbers to show where each side chain is placed. Amines, NH2, can be named as prefixes, amino at the start of the word, or suffixes, amine at the end of the word. In the same way, we can name the alcohols, the OH groups. They can be named as prefixes with a hydroxy at the start, like any other side chain, or suffixes with an ol at the end. Note that all these need an "an" before them to denote the C-to-C single bonds. In drawing organic compounds, you can either draw extended structural formula showing all atoms and bonds as lines, or condensed structural formula showing all atoms but not all bonds as lines. Either way, carbon atoms must each make 4 bonds, each nitrogen must make 3, each oxygen must make 2, and chlorine, fluorine, bromine, iodine, and hydrogen each make 1 bond. This reflects the number of valence electrons each atom has and relates back to the bonding and Lewis diagrams work we did in the first standard. A good connection to make. We need to also ensure that any oxygen or nitrogen atoms are bonded correctly to the molecule. Here are a couple of poor examples. In this one, you'll note that the carbon is bonded to the hydrogen of the OH. This would be marked as incorrect. And in this one, there's much that is not right about this, but you'll notice this OH is written the wrong way round. The O needs to be bonded to the main chain. Right, now just don't be scared of naming. If you take it step by step, you can name and draw even the trickiest molecule. Let's try this example. 4,4,5 tribromo 3-ethylhexanoic acid. Pause the video here and have a real go at taking it apart bit by bit. When you come back from pausing it, Here are some clues. Start by finding the longest carbon chain. That's hex, which is 6. The functional group is a COOH. That must be carbon 1. There are 3 bromine atoms from the tri. 2 of them are on carbon 4 and 1 on carbon 5. And there's an ethyl group of 2 carbons on C3. Pause again if you needed those hints. Take a look at this molecule here. You can see it has 6 carbons in its longest chain. Here's its carboxylic acid group, which is carbon 1. Here are 2 of the bromines on carbon 4 and 1 bromine here on carbon 5. And here on carbon 3 is the ethyl group. Note, an ethyl is a CH2CH3. Side note, there are a couple of errors on this molecule. Go back and see if you can pick them out. Well done. Keep it up.